All right, guys. I've got, the actual formal agenda has us just building a simple recommendation engine. I was going through it last night. This was material we used last year. I wanted to give you guys a little bit more. You have taken 2 days out of your lives to come. So we're actually going to do a little bit more than just recommendations. We're going to also do some like image classification and what's the other one? Word2Vec. So, and yes, we'll be using blazing text. I also have three, so I have one TensorFlow model, I have a PyTorch model, and I have an MXNet model. And so, right, like yesterday was all the sort of high-level services, the like AI services, and then today, yes, as you saw, we're more at the actual machine learning level is kind of how Amazon distinguishes. There's like the AI services, and then now we're talking about the ML services. And so we have 2 workshops today. So from now until 1 o'clock, and I think lunch comes around 1, yeah, which is very late. I wish it would come earlier because I'm starving. And then we'll do one again. I'm doing the same one this afternoon, I'm doing a new one at like 2:45 this afternoon from 2:45 to 4:45. That one's a beast. That one, I was up all night doing that one, actually. There is a lot of places. So this is this afternoon's one. I'm just kind of foreshadowing here. So the afternoon one's very advanced, where we're doing Docker images and doing builds within Jupyter Notebooks. There's a lot of command line. So yes, whereas today there's just, or for like this particular session, it's more just kind of Git cloning and then, you know, like doing Jupyter Notebooks. So I think this first one's going to be fun, and I'm just kind of really making you guys aware that the afternoon's a little bit advanced. I even got stuck at a couple places. So the short of it is you're going to see all like kinds of stuff today. So yes, everything from using sort of the higher level SageMaker stuff, meaning the high level ML services, and then the super low level building your own Docker container, building your own train.py file, and then deploying that to SageMaker. Okay, so this should appeal to sort of DevOps folks. That's going to be this afternoon, and then now is going to be more the practitioner. Okay. So quick note about me, I actually worked at Netflix. It was my very first time working with Amazon. This was in 2011. I was part of the original streaming team. Yeah, who here uses Netflix? Yeah, all right, so you're welcome, by the way, because that was my team. I was part of the global launches. First launch was to, I believe, Latin America. We chose Latin America because we could reuse the same regions within Amazon. You know, back then there were only 4 or 5 regions. We then launched in the like UK. We were following the like Amazon progression of new regions. We would find out where they were going, and then start building and starting to get content built up for those releases. So I think next was UK. I think shortly after was Norway, the like Nordics up there. We had lots of challenges, obviously, with closed captioning and subtitles and dubs. Certain parts of the world actually like to hear the raw English. Certain parts of the world want it translated and, you know, want the fake Brad Pitt, the like localized Brad Pitt. Yeah, these people become big actors because of their like dubs. So in some sense, I just joined Amazon about 3 months ago. But in some sense, I felt like I really never left, because my entire like last 10 years has been all rather basically Amazon stuff. So yeah, did a short stint with a company called Databricks, which does Spark, similar to like EMR, and a couple startups in between there as well too, all using Amazon. One little fun fact here. I joined 3 months ago. I made it a personal challenge to do all, I think it's 10 or 11 of these certifications. And I basically did nothing else. It was my first 2 months, not a lot was expected. So I did all of them. If you guys are interested, the like machine learning one is actually quite hard and was a lot harder than I thought. It's super broad. I think the other, you know, for me, probably the second hardest one was probably SysOps admin. That was one I thought I could just kind of coast into, you know, based on my Netflix experience, and then realized that there is a lot that's changed in the last 10 years since I started using Amazon. There's things like Amazon config, right? And that's ways to sort of manage configurations across organizations and multiple accounts. And I think actually the other hard one was the Alexa skill, because I had never built one before. So that one was actually surprisingly tough. The advanced networking is a beast as well too, but if you guys do have questions, just come ask me. I can give you some hints and tips on like how to pass these. I basically didn't talk to anyone for 2 months and just studied. Okay, so yeah, like enough about me. Let's talk about the agenda. We're going to talk a tiny bit about SageMaker. We had a really good intro, so not really much more to say there. We're also going to discuss how you would build a recommendation pipeline. We're going to talk about collaborative filtering. We're going to talk about how Netflix did this back in the day. They still actually use quite a lot of the same techniques. These are tried and true matrix factorization. I'm going to show you guys how to do this specifically with SageMaker. The two bonus things, we'll be doing word embeddings. We'll be using something called blazing text. That's a built-in algorithm. So SageMaker has these built-in algorithms that were discussed earlier. And then we'll use convolutional neural nets as well too to do some like MNIST, which is those little handwritten digits, kind of the like hello world. But I want to show you guys how to do it with SageMaker. We'll use TensorFlow, PyTorch. We'll use MXNet as well too. Okay. Of the people that do machine learning today, who's using TensorFlow? Okay. Who's using PyTorch? Okay. And MXNet? Couple? Okay, cool. So we have, it's all three examples. So as was mentioned, this slide actually doesn't do service to the full breadth of the offering. Today we'll spend quite a bit of our time actually doing all four of these, but we'll be inside SageMaker notebooks. We'll be using built-in algorithms. We'll be bringing our own algorithms. We'll be training, we'll be tuning, and then ultimately host these and doing either batch predictions or doing REST calls, sort of. So just think of them as single calls, right? Like single predictions to a like web service. Okay, so when building your pipeline, this could be any pipeline, not specifically recommendation pipeline, we have to frame the problem here. So, and then next will be explore and sort of prepare the data. This is often called feature engineering. This is where we're taking raw data, raw CSVs, like I showed yesterday with the forecast, and then like converting them into something that these models need and then understand. And each model, right, like blazing text, for example, has its own format where you have to put 2 underscores for the, like label for that sentence. That sentence has to end in a certain way. And if you don't prepare the data for these models specifically, then right, these models are just going to produce junk. After that, we'll actually train the model. In like some regards, training is actually the like most simple, most straightforward part of it, right? Yeah, all the other stuff really is where the like real fun comes in. Yes, after training, we've talked between yesterday and today. We've talked, I think, quite a bit about hyperparameter optimization, right? Like AutoML. Things like that. So I don't actually think we have a hands-on workshop on that, but I could point you guys the next step. You could actually take one of the current notebooks that we have and then add a little flag and then do AutoML and then hyperparameter tuning. So for some of you that do want to do that, like come ask me during the lab. I'm probably going to talk for about 20, maybe 25 minutes, and then we're going to start in with the labs. You could also do the labs during lunch. We're going to use the event engine thing. Hold off on that code for just a little bit. Okay, so let's frame the problem a little bit. Those of you, yes, all of you that use Netflix, let's see, how would I ask this question? 10 years ago when you first started using Netflix, who thought the recommendations were awesome? Nobody. Okay. Yes, me neither, and I work there, right? Who thinks they're actually pretty good now? Yeah, who thinks they've gotten better? Let's word it that way. All right. And yeah, the rest of you still think they suck. Okay. Yeah, thank God this is live streamed. Awesome. All right, so what's happening here? Yeah, obviously trending now is the most sort of, I think, yeah, so to me, this is the most exciting piece because this ties in to what like Liam was talking about yesterday, which is as the user's clicking around, I want to actually make changes and see what's happening. So there's sort of what I'm trending and then what the whole like user base is trending, right? So I can't comment on what Netflix uses today, and like mainly because I don't know. But yes, like 10 years ago, there was many ensembles coming together of like various models. If you recall, and I think I have a slide on this, there was something called the Netflix Challenge that was about 2006, I think, is when they launched it. And they actually launched this challenge to the public and said, hey, if someone can improve on our models, we will give you $1 million. This took about 3 years. Yeah, I have a slide on it here in a bit, but yeah, 3 years later, I think the winning solution actually had 150 models that had to be ensembled together. And this, at the time, 2009, right, like when they actually submitted and got above, I think it was a 10% yes, increase in root mean squared error, it was not feasible from a computation standpoint. So what Netflix did was kind of extract out, and there's papers on this, by the way, just right, like Google Netflix Challenge. There's been tons of papers on the like winning teams, the like winning algorithms. The big one that came out was called matrix factorization, which is called collaborative filtering. And it's a way to look at like the interactions between what users are watching, which, right, like, yes, how long they're actually watching, how long of a customer they've been, yes, how many reviews and stars that they've given, right? Like these things all take into account the like recommended movies. So yes, so said differently, a user who has been on the system for longer, right, like tends to be more critical, which is a little bit counterintuitive, right? Or like you could, I guess, like sort of argue it both ways. But the data shows that as people watch more and more movies, they actually become more and more critical. And so when a company like Netflix is trying to generate recommendations, those little sort of skews have to be factored in. And so that's really what the like final winning team almost like took into account. So when Netflix released their data, they actually gave a timestamp for these reviews. So it was some sort of arbitrary customer ID that was masked. Then it was the actual rating. Then it was the like movie ID, and then there was a timestamp. But like people didn't know what to do with this timestamp, right? Didn't seem like it should matter, but actually time was what actually won the challenge. Seeing how, and so not only was the user being on the system like longer, making it more critical, but there were actually movies that were in the catalog longer that had this. I think the term was Inception. Yeah, that movie Inception. Yeah. So like that movie didn't do so well at the beginning, but as that movie was on, right, like more and more people found it cool to tell their friends that they saw this movie, and it was really mind-boggling. And then suddenly, right, like that movie actually just kind of gradually got better and better. So yeah, so these things happen, right, like over time, just kind of human nature. There's like social effects and social engineering that has to be built in. Anyway. So let's switch gears, though. Let's actually talk about the data set that we're going to use today, which is one of my favorite data sets, very interesting, customer reviews. Who here has used this data set or heard of it, poked around? Yeah, OK. This actually pops in and out of some of our popular examples. I've pulled it in because I'm actually working on a project where I'm using Glue and I'm using the Athena and QuickSight, and I'm trying to gather everything into one continuous pipeline. That's one of my little side projects that I do with my team. And there's about 50 categories, I believe. And books, which is, I think, the fourth or fifth one down there, that one actually has the most reviews, because this is since 1995. I think I got a bullet point here. Yeah, 130 million product reviews since 1995. And so, things like Prime Video came along later, so there's just less reviews. So one thing, and this is something that we aren't necessarily going to do today, but what you would want to do is sort of normalize those reviews down to kind of the minimum. So find the category with the smallest number of reviews and then train and sample from all the other ones to kind of keep everything. Because, right, like otherwise books will then dominate. And so things that like we could do here is we could actually predict ratings. There's a star rating here, that last column. We could also, the fact that they even rated it means that they've purchased it or they've, right, like watched it. And so separate from the actual rating, right, like we could just figure out what, and find similar people based on what they've purchased, right, like separate from the actual text of that review or the actual rating. Yeah, one thing that's actually missing from this screenshot is the actual text review. You know, this product sucked, like, yeah, this product was great. And then something else too that we do typically is filter out the short reviews, you know, things that are just great and things like that, because they don't really add a lot of value to things like sentiment analysis and, you know, yes, other things that like we're trying to learn. Okay, so let's talk about the intuition here. So we have user one. We see that they've watched these movies. That's kind of how you can interpret the like. Yes, even like just watching it at Netflix, I believe at the time we considered a watch to be if they watched it for 5 minutes. If you watch it less than 5 minutes, we just discarded it and assumed that you were not interested in it. Okay, so what we want to do is if there's like two different users that look pretty similar, they've watched those, yes, 19 and then, yes, 87, we can then kind of infer that maybe these are similar users, right? So that kind of makes sense, yeah, from like the intuition standpoint. So this is what we call, this is called collaborative filtering, right? This is one of the 3 C's of machine learning. This is how I actually learned machine learning, which is there's classification, there's clustering, and then there's collaborative filtering. Those first 2 are, you know, pretty easy to grok. This, you know, third one's kind of goofy. But like collaborative filtering, so there's like item to item. This is something Liam talked about yesterday with personalized. This is a 2003 paper. This is actually one of my favorite papers ever. Yeah, I remember being at Netflix and I had heard about this because I started around 2010, 2011. I saw this, I like knew about the Netflix prize, which really focused on user-to-item collaborative filtering. Okay, so like just to kind of clear up the definition here, there's ways to derive similar like items. So if you have staple and then stapler, or yeah, so staples and then a stapler, those are item-to-item similarity based on purchase rightly history, and then user-to-item based on the fact that they've watched similar like movies, for example. There's something called the explicit feature. So if something is explicit, it means that the user has actually gone, they've taken time to say that this is a 5-star, this is 4-star. These are the explicit ratings. And then there's the implicit ratings, which is, so just the fact that they watched it means something. It's not as strong. In some cases, maybe, right, these ratings typically are 1s and 5s. People are just, from a human standpoint, very extreme. And so there's 2 ways to actually run these collaborative filtering algorithms, which is, should we take into consideration the actual like value of that rating, or should we just say that they watched it, they bought it, they didn't return it, so they like it? And so the way that comes up in the actual algorithms are, so like Spark, for example, yes, having worked at Databricks, I have tons of like Spark experience. There's flags you pass that say, right, the implicit is true, the explicit is true, whatever, into these, so Spark has something called alternating least squares, which is a form of matrix factorization, which I have a slide here, this next slide. So matrix factorization, this is a very, very generic slide, but what's happening is these are all the users for the rows and then all of the products. So when I was at Netflix, we had 20 million users, so we had 20 million rows, and we had 30,000 columns. Okay, so we had 30,000, yes, back then it was just movies. Right around when I left, they started to add TV shows, which was actually very, very hard like project, because we had assumed that it was, you know, in our data stores, right? We had one title and one video stream, right? But now we actually had to add another kind of grouping. Yeah, so that coupled with Netflix splitting DVDs and streaming, yeah, those projects, took like 7, 8 years. Oh, and then add in the fact that you could have multiple profiles within one account. Yeah, so all this, took about 10 years. But yeah, anyway, that's just kind of like sidebar there. So we have all these users, which are the rows. We have all the movies that they've watched or the products that they bought. You would have the value that they actually rated it 2 or 1, or if you're doing just the implicit, it would just be 1 or 0 that they did or like did not watch it or buy it. And then there's this factorization, and this is like just like an algebraic factorization, except extended to matrices. We're trying to end up with something with this small matrix times this smaller rank like matrix ends up like becoming that matrix. So in Spark, it's called alternating least squares common algorithm. It's like highly parallelizable, right? Which is why Spark loves it, because you can send to multiple workers, and then you could reduce and then get the values. But basically, it's like holding one side fixed. It's calculating this, and then it's holding this fixed, and then calculating that, and it's alternating, and then figuring out. So at the very end, you have all of these users with some value, 0.2, 0.5, whatever, and then all of these items with their values that were factored out. It will never be completely equal. It's just an approximation. What you could do then is for this particular user, for this particular item, I could just multiply those and figure out what the predicted rating is. Okay? And so then you would sort and then figure out when this person logs in, you would do this calculation. You would basically take this entire row, multiply it by all of these columns, and then sort that, and then figure out the top 50 to show them. Okay? And there's lots and lots of variations on this, lots and lots of like different implementations. In SageMaker, this is called factorization machines. And this is what we'll be doing today. One trick that you'll see in these notebooks, so with ratings, right, like this makes sense. 5 versus a 2, right? Yeah, so this is actually significant. The value that's in that column is significant. When we're dealing with like movies, and yeah, basically, yes, anything with an ID, right? So that number doesn't matter, or should not matter to the algorithm. 4 does not mean it's better than 2. Like, yeah, so this, like movie ID, if the next one was 6, yeah, so 6 is not better than 4. So what we do is this process called one-hot encoding. And we take each of these, the ones that we don't care about the actual, that value doesn't matter, and we do all zeros. So if this was 30,000 movies, yeah, this would be a huge row of zeros and one and just one, okay? At the spot that will represent that ID. And so this is very important because when you're doing this matrix math and learning and right, like trying to learn what these latent features, that's what these things end up becoming. These values that are in here, there's like latent patterns, right? That term latent means hidden sort of pattern that you can figure out, right? Like once you've actually factored this out. Okay, so when we're doing that, we don't want to skew and learn something that takes into account, right? Yeah, like those IDs. And so the way to do that is to just normalize between 0 and 1 and then build yeah, these one-hot vectors.
I have a quick question. Is this data set sparse data set?
The question is this a sparse data set? Yes, this is a sparse data set, yep.
Would it make sense to look at PCA for reduce the dimension?
There's lots of different, yeah, there's lots of different things, yep. Yeah. Yeah. So the question is, yeah, so like I said, so Spark, you would actually tell it that this is just 1 or 0, and that this is not a rating, but this is just a like or a watch or a not watch. Yep. But Yeah, yeah, right, like exactly, buy or not buy.
But you don't need to have, can you have like how many target pages?
Yes, yeah,
That could be also like.
yeah. Yeah, lots of different spins on this. If you check out that item-to-item thing, yeah, by like Amazon.com, that paper is really, really good. Okay, so here's the next version here. All we're saying is the 5 and the 2 stay the same because that's significant. And here we're just putting in 7 over here into that 7 slot, and it's the same user, so 0101. All right, so like I said, training is kind of the boring part here. We're going to use a SageMaker notebook. We're going to get some data out of S3. The data is actually going to be pulled from a public bucket that is part of the Amazon public data sets. Yeah, not sure if you guys have seen that. If you search right, like Amazon and then public data set, there's a whole list. There's all of these data sets that are in S3 that are free to use, free to download. And this is one of them. So we'll actually pull that today. We'll actually train this using SageMaker. We'll use factorization machines. We're also going to do something kind of clever, which is we're going to use Word2Vec, or right, like blazing text, and do recommendations that way. And that like notebook, sort of outlines yes, how that works. So it's an algorithm that is traditionally used for text processing, but we're going to apply it to product recommendations. And yeah, like we'll see how that works here in a bit. Okay, optimization, like I said, I'm not going to spend too much time here. There was a lot of announcements at like reInvent. Probably later today, I think before the next workshop, I'm going to do a quick recap of the 5 or 10 key things that came out. So things like AutoML, yeah, so from like reInvent. But just keep your eye on more and more hyperparameter optimization and then AutoML stuff that is now available with SageMaker. Okay, once we train and then optimize the model, we then host it with SageMaker. What I've come to realize, actually, even in the year before joining Amazon, when I would talk with people about SageMaker, they always associate it with the sort of model hosting, right? Like pushing this out as a REST endpoint, and people are like, well, I could do that on my own. But yeah, so SageMaker is obviously more than just hosting. It's doing training, it's doing optimizations. There's, yes, all kinds of stuff. Model monitoring, yes, tons of stuff that was mentioned this morning and then yesterday. But when it first came out, I think the most fun part was, or the sort of early examples were like all around creating a REST endpoint that you would then integrate with your application. So here's a classic like deployment scenario. You've got your API gateway where you could do, right, like web firewall, like protection and denial of service, all kinds of stuff here. We're going to invoke a Lambda. Of course, we can't have an architecture without Lambdas, right? And that's going to make a call to SageMaker. Now, you could actually connect SageMaker to Kinesis streams. So once that endpoint's created, you can integrate it from like anything. And but there's also those batch predictions that like were mentioned right before, where you're not actually calling the REST endpoints, but you're actually kind of getting in deeper beneath the covers and doing batch predictions. So I should mention too, just to tie this back to this example, when I said that once we get these factors, so this is like typically called an item factor like matrix, and then a user factor matrix. And if you remember linear algebra, that dimension times that dimension has to equal that dimension, the full dimension. So once you get these factors, what then happens is nightly, we would then just do this massive calculation, and then at like Netflix, we would store the results in Cassandra, and it was per user. These are the top 500 like items that they will likely want to watch when they log in next. Yes, obviously this has become more and more real time with the trending now and all that. Yep. Correct. Yeah. Yeah. There's these latent the way that that I think of it is if you just look at the matrix of here's my user, this is the 10 movies that they watched. There's patterns that are in here that the human's not going to catch, but yeah, this will extract it out. Yep. So that was one of the big realizations from the Netflix challenge. Okay, so deployment, I think we got there. Bonus material. So I want to mention this because it is relevant to the workshop. There's this concept called the embeddings, and these don't just have to be 4 words. Yes, all of machine learning, if you step back and kind of unlearn all the algorithms and the specifics and the terminology that like we've learned the last couple days, yes, all we're doing is taking one set of data and we're translating it into some like alternate representation. Okay. In fact, there's a really famous conference called ILCR. Yes, ILCR. It's basically it's ICLR. Something conference, and then learning representations. We're learning a new representation of a data set, and yes, hopefully picking new dimensions or a new vector space that means something, that will let me split that data or classify that data or cluster that data separately. So this is all machine learning is taking something that's sort of human grokkable and then like somehow getting it to where we can then apply human grokkable slicing and like classifications, similarities. So this is a case, and so this term is typically called the embedding, right? Like an embedding. When we're doing word stuff, we're going to create what's called word embeddings. If you've ever heard of like word2vec, or basically, so within SageMaker, there's something that's just called object2vec. So basically, you can take anything and then create, right, like an embedding out of it. And what you're trying to do is, find these similarities. So this is classic kind of hello world word embeddings, but you can. So with word2vec, these words end up being very similar, and you could actually then project and figure out that swimming, that vector is pointing to something called swam, which is past tense. This is present participle something, going to past tense. And then this is pointing, so king points to queen, so you can kind of subtract them out, right? Here we've got, very common Spain to Madrid. So based on a corpus that we passed in, these words, when we converted them to this new space, right, this like alternate representation, when we learn this, yeah, so then we can start to do cool things, like similarities. The other thing we'll do is the hello world MNIST. This will be with SageMaker TensorFlow support, SageMaker PyTorch, SageMaker MXNet. I'm not going to go into the details here. Yeah, convolutions are really cool. What you're trying to do is, in a similar way, you sort of start off with no knowledge of this image and just kind of traverse across and then figure out and find edges and then go deeper and build upon. So this is where the deep neural networks, this is obviously a very deep neural network. We're then pooling to kind of keep things not sort of overfitting, I guess you could think of it as. And it's kind of slowly going around and then figuring these things out. So this is what we typically start with. So so yesterday, we were talking about recognition. So recognition was trained on millions of just sort of generic images. And the output could be car, truck, van, there were thousands of these. The problem that the recognition with custom labels that just came out during reInvent solves is I'm not limited now to just car, truck, and van, or piano or duck or whatever. Now I can actually point it to my domain. So I'm sort of starting with all of this knowledge that's been picked up from all the models or from all the data, right, that I've been training on, all these images, and I'm just fine-tuning or transferring this knowledge called transferred learning so keep all the knowledge that you have, but just train the last couple layers on my new domain, which could be specific to your product catalog. Okay. Let me do a quick demo. Then I got to upload the latest code before you guys get at it. That's why I've been having you hold off. So I want to run through and just show you guys. Yeah, I noticed yesterday people ended up in different states and there was a lot of chaos. And I want to show you guys the happy path so that you get something out of this before you actually start, getting into the weeds. So probably do the same thing for this afternoon as well too. All right, so the context again is we've been given this data set. Let me see. There's the data set. We're actually picking one piece of it. Something I realized last night is the training takes a crazy amount of time on the full, I think it's like 2 terabytes or something. So I'm just doing digital video. So this is, this is, I think, Prime Video. Or no, this is digital video download. And here's some of the data. So you see product ID, product category. Here's the rating. Looks like there's been some new columns added over the years. Here's the review headline. Here's the review body. So we're not printing it all out because some of these get pretty lengthy. And then here's the date. Yeah, right. So again, don't forget about the date. We probably won't, or actually, I think we do actually use it today, I think. But we don't explore it as much as we should for like a full situation. Okay. One thing that actually took me a while when I first joined Amazon was they have something called the ASIN. Yeah, there's a lot of acronyms, of course, with any big company, and that's basically the product code. So if you go reverse engineer the URL next time you're browsing around, you'll see DP/ and then that's the ASIN. That's like the most important value across all of Amazon.com, it seems. Okay, creating a data frame here. So basically, pulling in this data, trimming out anything that is kind of junk, sort of junk reviews. We're going to split the data into train and test. So this is matrix factorization. There's no time series here. If you were doing time series analysis like I talked about yesterday, and then mentioned just now earlier too about trying to figure out how long, well, actually figuring out how long that user has been in the system is very easy. That can actually be derived just from the very first review or some subscription start date, and then you would then subtract that out and then add that as a new feature. So that's actually not that bad. But here's your sparse matrix. The target variable is what we're trying to predict here. So we're actually trying to predict the rating. These are the sparse matrices that have been one-hot encoded, like I mentioned before. And one thing about these built-in, so if you're using something like factorization machines or like blazing text, yes, like I said, there's formats that these models need you to get the data into. And for matrix factorization, for these factorization machines, you have to get it into something that's called protobuf. So this is boilerplate code that you can grab from, any example. And this is basically turning CSVs into this binary representation that factorization machines needs. You want this. People always hate doing this. I hate doing this. But for performance, you want this. This is a huge difference than just passing in huge CSVs that are not being converted into binary protobuf. So just a necessary evil. Okay, this is where the magic happens here. We're creating this estimator, passing in similar things. What was mentioned before, I'm saying use factorization machines. Use the latest version, not like a particular version point in time. That's okay. I have one instance count. You didn't hear this from me, but if you do try to up this number, it might work. So try it if you want. Don't get too crazy, otherwise I'm going to get in trouble. If all of a sudden we take up all of US East, which I doubt will happen, but. And that's the instance type. So C stands for basically CPU. So C5 means CPU optimized. If you have an M, that's like typically memory optimized. If you have a P, that means GPU for some reason. And then I think is disk or is like IO optimized, things like that. We're setting some hyperparameters. Those were mentioned this morning. I think he brought up a kind of an advanced hyperparameter, or yeah, not advanced hyperparameter, but not like an intuitive one. I would say hyperparameter for me would be like if I'm doing decision trees and I'm trying to figure out what's the best depth of my tree that I am willing to train. Yes, obviously the deeper the decision tree, the longer this is going to take to train. This is matrix factorization, so this is number of factors. So this is actually going to be, that's one of those dimensions. That's the inner, let's see, how does it work? Yeah, so that's a hyperparameter. That's basically, how many factors are you willing to pull? And so this is something you literally just have to play with. The way I see people do this, if you have no idea, and one recommendation, if you are handed a model like factorization machine, obviously read the documentation, get some best practices, maybe find some like academic papers or find someone else that's doing this that chose 256 for this hyperparameter and it worked for them with a similar data set. If all else fails, start with 1, go to 10, go to 100, and sort of do it logarithmically, exponentially, right? And then kind of find out where it is. That's just sort of a like practitioner tip. So said differently, if you don't know where to start with these hyperparameters, or if some example has been given to you that's completely off, then just do 1, 10, 100, just keep training until you get good accuracy or recall whatever you're actually going for. All right, so this model was trained. So what happened here was, in the background, this spun up the C5 extra large. I only chose 1, I was being good, and keeping my fingers crossed that it would at least work this morning when I tried it again. Here's the logs. So this is actually significant. And some of us don't want to have to look at these things, and that's fine. But keep an eye here, because there's actually some pretty interesting things that could come about. And then one thing you'll notice is for all of the Amazon built-ins, they're actually writing out metrics, and these end up in like CloudWatch. And then you could use CloudWatch to actually compare runs, right, these training runs. And then I could sort by best accuracy and then figure out what were the hyperparameters that were used to find the like best accuracy. Okay? When you're doing your own model, which we'll do this afternoon, you have to actually write like this little regex expression that will pluck this out, either convert the JSON, or it's basically dealing with, yes, individual log lines. It's pretty painful, but it's the price you pay when you want to get in at that level, right? So this is that balance between like having flexibility to be able to do your own models or just using somebody else's API and it's a total black box. So, but here this is actually a pretty good like combination. Like you don't have to do your own regex. These will end up in CloudWatch and you could test it when you get there. Here I actually deployed it. So this is factorization machine.deploy. I tell it the type of instance. These like burner accounts is what I call them, the event engine accounts. You actually do have 6 or 7 different instance types you could try. You didn't hear this from me, but if you try a P3, it might work. Just don't do it all at the same time and don't tell them that I had anything to do with it. Okay, and then it's serializing. So this is how we're actually taking the raw output and then converting it into a nice feature that then gets, or a like nice response that then gets sent back to the application. So here's what we got. So this is our, I think this is going to be doing a batch prediction actually. And for this particular customer, for that particular item, so customer, and then this item, looks like it's my dear secretary, the predicted score is 3.88. And so wherever that falls relative to the other products that I've calculated, and so literally this call is doing that one factor times that other factor, that like user factor times the other factor, and like literally, yeah, so that, so that single, right, like dot product will end up with 3.88, and that's the score. Some of you might be asking, okay, that's great for one single combination of a user and an item. Yeah, how do I get all of them? How do I sort them? How do I, and that's the batch processing that happens on the side. Yeah, question?
Yeah, the instance that you just showed, like 2 seconds ago, that didn't have to be the same as the instance before?
Good question. Yeah, two separate things. So, and I'll make that clear here. We trained, the question is, this instance type is so this is the training instance type. And I had P3 in here last night, but pulled it, so I didn't get in trouble. So that not, right, like 150 or whatever people here. That's training. C is CPU optimized, so that's going to run faster than if I use like a T2 or something small. Yeah, so I want these to train fast. Now, what typically happens, yes, typically we are going to train with the GPU, so that would be like P32XL, and then I would deploy that model on a C5 or a C4, something CPU optimized. There's typically not a whole lot of benefit. This is actually changing quite a bit with a newer version of like the NVIDIA GPUs, and then yes, Amazon has that new chip. I think it's called the Inferentia, which is optimized for the like model predictions and then model hosting. So this is doing different kinds of math than the actual prediction. This is factoring things. Whereas prediction, I'm just doing fast multiplications. And also, the big difference too is with GPUs, you want to do them batch, huge matrices, and fill up those chips, right? These chips have thousands of cores, 5,000, 6,000 cores. So at training time, we have all that data because we have all the movies and the sparse, those sparse matrices. When I'm doing predictions, I'm typically doing, so not just one, but I'm doing, maybe hundreds at a time, not millions, okay? So the hardware does matter, and think of it like a hyperparameter, right? Like you don't actually know what's going to be the best, but a general guideline is GPUs, because of the way the hardware has been built, is good for training, and then CPU is typically good for the actual predictions, or like good enough, right? Also, cost is a factor. Okay, so let's see. I think it's just more of that. Now, to tie this together, let me show you guys. If I click on endpoints, well, actually, I'll first show you guys training jobs. So I ran all these this morning. The training job that we're looking at right now is, I think it's this demo loft recommender, which is the factorization machine. So this is the one that I ran before. We could look at the history. We could look at some metrics, see the instance type. Okay, so these are all the metrics. Now, they've already done all the regexing for you. So that's the good thing about using one of these like built in, right? If I had to bring my own, which we'll do this afternoon, I'm going to write this regex and then pass it in when I train. And that's going to end up putting some value. So these are all the metrics that I'm going to go into CloudWatch and sort and find the metric that I'm trying to optimize, which is typically validation accuracy, in some cases recall, and then sort and then pick the one that had the best hyperparameters. So parameters should be here. Here's the hyperparameters. Okay. This is for just one single training run. If you remember, we did 256 for the number of factors. Yes, epochs. This is what like Roger was talking about this morning for his hyperparameter. So these are the things that you have to sort and then figure out which ones are the best. Now, there's something called hyperparameter optimization that will do this for you. You actually give it a range and say, I don't know if it's 256. I'm going to give it 64. I'm going to give it 128, 256, 512, right, like 1024. And then when all these runs are done, you would then go into CloudWatch, sort it, or ask like SageMaker to like give you the best one. All right, so that's a training run. Here's an endpoint. Endpoint is kind of a weird term, but if you think of it as an endpoint for your application to call, and this is the equivalent, this is that same model that was pushed out, and here we could actually see metrics, CPU utilization. Disk usually doesn't matter too much in these things. And let's see here, let me try to stop scrolling. Invocation metrics, yeah, those are actually interesting. So this is a deep link into CloudWatch. And I could actually see a graph here. Let me zoom out. I could see 500s, which are errors. I could see 400s. I could see model latency. Select one of these. Yeah, so I only made one call, but yeah. So, and then from here, you could actually set up anomaly detection. This is something new with CloudWatch. I think it came out October or something, where you could tell it to keep an eye on latency or 500s. Maybe there's a normal number of 500s coming in your system, hopefully 0, but yeah, typically not 0. But if your latency, yeah, so just point the metric anomaly detector at a single metric or combination of metrics, and then you could set up an SNS alert to notify you and like tell you what's going on. What's cool too is that you could actually, and I don't think we're going to talk about this too much today, but you could actually set up and track the confidence of your predictions. So with every prediction, I'm getting some kind of confidence, right? Gone are the days of just getting a prediction. That's not good enough. I want a prediction and know that this is 80% confident, this is 90%. When you first deploy your model, let's say it's a fraud model, and now we're seeing 90%, we're doing pretty good, right? Like recall's doing well, right? Like we're not burning money, we're not like pissing off customers, it's a nice balance. But then suddenly something changes. There's some fraudster figured out the model, and now there's skew or drift. And that's when I want the actual data scientist to get notified at like 2 in the morning, not the ops guy. The ops guy is fine because the service is working. Yes, all the system metrics are working, but the system is in a potentially degraded state, okay? One very, very brute force that thing I've done in the past, if you don't like hear about it for the first time, it seems obvious when you hear about it, but we would actually track when we would get 0 search results. So it's a very, very bad experience when someone searches and gets absolutely nothing. Some people would argue I would rather have nothing than complete garbage, but we always found that when you show someone 0 results, that was bad. So we had a metric set up to be tracking 0 and then notify. And that meant something was wrong with Elasticsearch or didn't have enough content. We would then send to the content people. People are actually searching for these things. Okay, what's next here? So actually it's 12, and I do want to give you guys time to go through these. The blazing text recommendations are pretty fun. What it's doing is it's actually building up. It's like utilizing the fact that blazing text, let me just get to the main picture here. Sorry if I'm driving you guys crazy with the scroll. So if you remember, I showed you earlier on the slide, we could do, this is an alternate representation. So, yeah, so let me step back a sec. We've built up line or sentences that have the movie, that have the review, that have the like category, that has all the kind of like textual info. And so the way WordDevec works is if sentences are grouped together, or words are grouped together commonly in sentences, then those are similar, right? And so this is an alternate representation of all of our reviews. And WordDevec has then put it into this alternate learned representation where the human can then look at it and start to see groupings. If I zoom in, it doesn't really help, I'm sorry, but we see all the, is it Downtown Abbey, Downton Abbey? Yeah, right, like Downton Abbey stuff is together. Yes, I always call it Downtown Abbey. Star Trek things are all kind of grouped together, people, right, like Hunger Games. So this was all learned, and yes, you'll do this as part of the exercise by, right, like taking textual data and getting it into a kind of a into blazing text format, but now we're actually generating recommendations by using nearest neighbor, right? So now we could actually look and see if the person watched Star Trek, they are probably also into the Hunger Games. And that's all based on the actual text from the reviews. Not a very well-known technique. I was actually surprised to see it when I stumbled upon it, but it seems kind of cool, and it's fun to play with. And all that's in here. So yeah. That particular image doesn't get bigger very well, but yeah. Okay, and TensorFlow here. I'll just show TensorFlow, PyTorch, MXNet follow the same pattern. What we're doing is we're making sure, so something I always do is I always, and this is probably not a recommended thing, I probably shouldn't say this, but I always start with my own just base kernel, and I don't want any of whatever the SageMaker notebook has deemed is the right TensorFlow kernel for me. If you're just kind of a casual user, but here I actually wanted to use TensorFlow 2.0, a specific version of NumPy, I had my own requirements. And when I use those kernels, right, that like Raja talked about this morning, they come with a lot of opinions on their version of what NumPy should work with which SciPy, and those typically aren't what I want to do. So the tops of a lot of these notebooks are doing uninstalls of like whatever crap might be there and installing exactly what I want. This is a Python hell kind of situation that we all know about from pip install. I actually could be using Conda actually because this is Conda, but for some reason I'm stuck with pip. Also, these notebooks tend to, when you're on like the latest TensorFlow and latest PyTorch, tend to have issues with certain parts of the stack. Like for example, that tsne thing that I showed here, it's called tsne. It's a way to flatten this image. This rendering didn't work as of like 6 a.m. this morning because of a like library incompatibility. So I had to hack it together to get the right version. Okay. What we're doing here, so yeah, besides that, and then just showing which libraries are actually in use. SageMaker has something called a session, something that you actually want to use where possible, because it's going to make things like getting the region name that you're currently in very easy, getting that IAM role. These SageMaker notebooks run as a role. You can then add policies to S3 and do the least privilege, right? You could just give this role access to the Amazon reviews data set and nothing else in your account. Okay. So training data, pulling that data locally. Yes, I'm actually pulling it locally. I didn't have to, but I'm showing how to do that here. Printing out some code. And then this, again, is where the rubber meets the road here. This is the equivalent. So the other one, we did SageMaker, just a generic estimator. And then one of the parameters that we passed to the estimator was blazing text or was factorization machines. Here, there's actually a first-class citizen called TensorFlow. I tell it which version, 2.0. I give it the instance type. This was P3 yesterday. If you try it, it might work. Instance count 1 or 2. Actually, I don't think 2 P3s will work, but 2, yeah, like 2 of those should work. Here's some regex. So this is a case where I actually do have to do my regex and pluck out the accuracy. If you're doing distributed, if that count is greater than 2, then you have to turn on parameter server. You could turn it on anyway, but it just won't do anything if you only have one node. This is for distributed training. So parameter server is a separate cluster, basically, that is gathering all of those gradients and then averaging them from all the workers in the cluster, and then propagating them back to the node. So this is very important for distributed training. And there's the regex. So here I have a little comment to myself because it took me forever to figure this out. This is what the log line looks like. This changes from release to release, by the way. TensorFlow 1.15 is a different format, and this regex changed when I went from 1.15 to 2.0. So said differently, you can go this route, or you could just use the SageMaker built-ins, right? And then you don't really have to think about this stuff. Here's the fit. This is a call of the fit. One thing you could do when you call fit, this is something I always recommend, say weight equals false, and that's going to do an async. It's going to return you the name of that training job, which you can then, anywhere else in the notebook, you could reattach. And the reason I say this is I've done enough workshops and just got back from reInvent, where we did tons of workshops, where this cell runs for 10 minutes and then the notebook dies and we don't know the name of the job. So this will right away tell you what that name of the job is. I could shut down this notebook and then call it back up, start from this line, and actually see the logs and then watch it finish. One thing I like to do in my notebooks, in my samples, is print everything out where I think things should be. So up above, when I did this TensorFlow job, this training job, I told it to put the output, to put the model in this directory that I built right up here with the region, or yeah, with the bucket, and that's the variable. And I'm going to use that variable later on to do an S3 dump and show me that that model actually is there. Show me what are the contents, and it is going to append the training job name. So there it is. My model's been trained. Typically, the way that SageMaker works is it tars it up, and if it's a Keras file, it'll be an H5 file in there. If it's TensorFlow, it'll be the save model format. If it's PyTorch, it's whatever PyTorch uses. Here's the save model format from TensorFlow. Here we're then rehydrating. So this is actually option number 1 if I want to just do predictions in the notebook. Here I'm calling load model. That's the export directory that I extracted that model.tar.gz. And then here I'm printing out the signature of that model. If you've never seen this code, it's because most people don't do this for their samples. I like to do it because I want to show you guys the techniques that have been super helpful for me. This tells me if I'm handed some random model, I could run this particular Python call and see what's the signature of this model, right? And by signature, I mean what are the inputs and what is the output that's coming out? What are the dimensions of those tensors or those NumPy arrays? Super valuable. And here we're actually, so then there's option 2, which is what most of the time you see, which is you create this magical SageMaker endpoint like we did with the factorization machine. We call deploy. We give it the instance type. So again, here we trained with potentially a different instance, but here is a new instance type. Once that thing gets loaded, we then call predict. This actually, we did a batch prediction on that endpoint, so we passed in a bunch, I think it's 50, and then made all the predictions and got all 50 back. This is something someone asked me yesterday about the pricing model with these APIs. Typically, it's transactions per second, and there's a certain minimum where they're free, so you could do 10,000 calls for free. But one recommendation I always make is try to batch up as many of these as you can from the application level. This means writing lines of code that will wait 50 milliseconds or 100 milliseconds and gather all of the predictions that need to be made coming in from all the different customers that your app supports and make one call. And then that's considered one API call. That doesn't work with all the services, but you have to keep an eye on exactly what the pricing model is. But that's one trick I've seen people use. Basically, sending in a larger payload and then being able to accept that like larger response and then send it back to all the callers of that API. All right, PyTorch and MXNet are almost exactly the same, but in their respective situations there. Okay, let me clear. I'm going to clear these. I'm going to check them in, and we could go the next 40 minutes. I'll be floating around, and then during lunch too, of course, I'll be here. So for the original thing, it was just blazing text and then factorization machines, but try to get to the other ones as well too. Okay. One sec here. Okay, do you guys remember the URL for the event engine? Probably not. Let me show. And exactly, I was just going to say yellow piece of paper, yellow code. We are only going to use the yellow code. I'm in total control of the workshops today, so I was able to make that happen. Between me and you and all the live streamers, I didn't want to tell the loft because I still wanted you guys to get the credits. So $70. I guess you have to actually burn through the credits first. Did Linda say that? You have to burn through yesterday's before you can apply them, and I think they're good for a year or something. So. It says the event is not running. Let me see. Did anyone else's work? Okay, and make sure that you log out of the current account that you're in. Okay, the event looks good over here. I see people getting in, so is yours not working? Okay, use the yellow code, yep. Once you get that going, go to, don't go to that. Go to this GitHub and follow the instructions. Yes, any questions? Hey.
Why are we doing this and not just cloning your GitHub?
From your.
So you have to log out.
keep the white piece of paper for yourself for the future. All right, there's people, sorry. There's people that are trying to use their own account or don't realize that they're using their own account. You won't have enough limits or any, so stick with Event Engine. Log out of your personal account if you aren't not using Event Engine. You could tell if you're using Event Engine because in the upper right, it'll say the account name is team role / master key. If you're doing that, then you're good. If it's your own corporate account, this will likely not work, which is why we have Event Engine so that we don't have to, right, like muck with your guys' like personal and corporate accounts. The workaround when you do this later on today or this weekend is to just change the instance type to something that your account has, but I can't support you today if you're doing that because then you'll be off the rails and it's hard to help out. Yep. Yep. I would stick with Jupyter. Someone just asked Jupyter or Jupyter Lab. If you're in Jupyter Lab, it might cause problems. I didn't test it with Jupyter Lab. Open AWS console. Yep, same as yesterday. And then log out. Can you go back to the link again? Okay, so once you actually get into Jupyter, run each cell like very carefully and make sure that you're actually reading what it says. There's a couple places when we do pip installs inside of a notebook where we have to restart the kernel for those pip installs to get picked up. So if you see issues with that, let me know. Yeah.
I had a question about the matrix factor. I was wondering, when we're multiplying the user matrix by the item matrix, we're doing that to produce user recommendations. So it's for a particular user or for all users? I see. So then why is it not just a user vector with the item matrix?
That's what you would. Oh, okay. So
Yes, is there anyone else having problems getting to the S3 bucket? Okay.
I think once this is not a store record,
Thank you so much.
I think, if we'd done it on the spot, we would have pulled more, or if you'd said,
Yeah, I completely forgot about that. And I was trying to remember what we did yesterday, but yeah, we ended up not doing
you've got
anything.
40 people sitting there watching, if you want to go and say on the mic, and you see on the live stream, look at the comments.
Good question. And I'm looking. So I read about Jupyter and notebook and that. The rubber words. Like why why do you use Jupyter? What's the purpose of this?
What would you think to use or want to use? Yes. So I guess ask definitely, are you a developer that works in IDE? Yeah. Yeah, so you're like me. I rejected them for a long time. What's different is you and I, when we're writing code, we're not generating plots and statistical, showing separations. That's the difference.
So it's pretty much the same.
Yeah, and collaborative, the collaborative part of it too. Typically, I don't want to have a wiki in my code until I push it to production. Right? Like me and you just sit at our desk. We might pair with one or two people. In data science, people are sharing these notebooks. They're summarizing data,
So it's pretty
sharing
much
it
an
with the
IDE.
CEO.
It just showing you what's happening. Okay.
It's like because the downside is, as you probably noticed, if you run a notebook out of order, if you accidentally skip ahead or something,
Yes, it's a sequential process. That's why I was generating a lot of errors.
Yeah.
Even though,
Yeah, so like run them slow, make sure everything's happening.
what is the alternative to notebook?
That's it.
Is that notebook? Is it an R experience? Is it available on R or? Is it
Yeah, R, this dates back to like Mathematica, R, where through and see, okay, this notebook, this code with these hyperparameters produce that graph.
Can I have multiple notebooks talking to each other, or it has to all be like in one notebook?
Yeah, there's hacks to do it, but
You actually have
So typically it's not.
if you want to do the
Yeah.
full one,
And that notebook, it just, once I release, let's say, an API REST endpoint, can I see the visualization of that beginning of the notebook, or that's more of a log?
So when you're calling the REST endpoint
Yeah.
from the
App my app.
notebook, yeah, so from the notebook or
From an app.
from an app, right?
Oh no, that's just
Yeah, the notebook at that point has
It's the same
something
example
to
as
do.
an
Yeah,
app.
yeah,
So, okay.
yeah.
So more of just like seeing the logs. And I can log stuff in the notebook. Like
Yeah,
that.
yeah. And if you're not really familiar with like Seaborn and MapLogger, I heard that stuff, but they're absolutely crucial to this kind of stuff. And it's more, right, so you and I think of how to productionize this for the long term. These notebooks are for sort of ad hoc analysis. I've been given a data set where there's a fraudster that just figured out our model. Let's try to figure out what it is. And people build these notebooks in an ad hoc way and either version them or they just throw them out. But at the end of the day, they're literally like copying and pasting that code and putting it into the production library.
And that's
the reality of it today.
It's like what we're using production. So it's the same thing as well.
Yeah, so for example, what we're doing today is we're using the notebook as a way to explore the data and then call SageMaker to train a model and productionize the model. So our workflow ends with a model that's in SageMaker that can then be wired up to the application to make those calls. So some people take the notebook and cut and paste the Python code and like just literally have a code that runs that or puts it in Jenkins. I've seen massive machine learning pipelines with Jenkins with GitOps where they make a change to their train.py. And then that builds Docker image. We'll be doing more of your kind of fun. Yeah, we're fun stuff later this with 245. Where we're going to build a Docker image. We have a train.py pipeline that we're going to slurp into the Docker image and productionize that. Yeah, SageMaker lets you do it at multiple
And
levels.
let's say like I'm interested in that stuff. What do you do like that's like beside the courses thing? Is there like more of a collaborative labs and things like that?
Yeah,
Events that happen?
here there's, yes, I live in like San Francisco, but it's similar here. There's a school called Galvanize, and as long as you're, it's a pretty tough process to get to, just as long as you actually have some statistical ability and some Galvanize, G-A-L-V. So when I'm looking at yeah, I did say V-A-N-I-C.
And what is that?
They're like boot camps. People take time off work. 6 weeks or something. If you can't take time off work, I just go to a bank, find have a regular meeting right now.
Oh yeah, it says training product development. They don't.
Hello, ladies and gentlemen. Good afternoon. Me again. Just want to let you know that lunch is going to be served right after this message. Meat selections are in the lobby. Vegetarian selections are right in the kitchenette area. Please help yourself to soft drinks and assorted sodas as well. They're in the fridge. Thank you.
Yeah, we all kind of have our own company, so we all kind of have our own company. Fixed strategy.
One guy who does other people. Well, he still works. He would just.
Yeah, so I was working with actually technology startup until summer.
Yeah, I mean, like, he knows how to. He may know. I mean, we do that. So when something happens, the company may have to file like a report, and some parts of that will be some parts of that will text, the text parts you can post. So but I mean, we wouldn't actually focus on it. We would look for flags and triggers. Probably like certain industries, we would have to talk about caption one. I don't want to know too much about that. Yes, Drew.
factorization demo, I broke it when I did my commit. When I was showing you guys that you could change num_factors from 1 to 10 to 100, I somehow committed the 1. So 1 does not work. Some of you have seen it. A couple people over there have seen it. Let me just show you the thing right here. The short of it is, if you're having an error with factorization, just go on to the other ones. And those should be okay. The specific line of code is this right here. And this is the factorization machines, and that used to say num factors equals 1, the version that you guys got. The savvy of you could actually go and do a git pull. You would go into terminal, go into SageMaker, find that directory, do a git pull, you'll get the latest. If not, just go on to the other ones. A couple other questions people asked, really good questions, is why are we using estimator here? This is actually a Python like base class, if you're familiar with object-oriented. And in this case, and it's really, in my opinion, I don't know this team super well, or the person that actually implemented this code, this SDK, but this was the first generation of SageMaker sort of APIs. And what you do is you customize it by passing in factorization machines, which is off the screen here, as a parameter. That makes that a factorization machine estimator. Okay? In blazing text, we should see the same thing. If I search estimator, we should have the same thing, except, so there's my base class estimator, and I'm customizing it and telling it this is actually a blazing text. And internally, it's using subclasses and doing all the normal fancy stuff that you would expect from a well-designed SDK. Now, the question is, why am I using, in my TensorFlow example, I do the same thing and search for estimator. Take a while, find that. Why is this not using estimator? Why, if I search for the word estimator, and my hunch is it's just kind of the evolution. Internally, because I've seen the code, this is implemented as a subclass of the estimator. And you can go, and this is all open source code. This is all open source code because it's calling the Amazon Web Service behind the scenes to actually provision the resources to do the training. Okay? So good questions there. I want to highlight something while I have your attention. Towards the end of 2018, Amazon partnered up with Facebook. This is something called the Deepfake Detection Challenge, DFDC. This is something I'm particularly passionate about because I think this is a very, very dangerous thing that we need to combat. So what's happening here is Facebook has put up a Kaggle challenge. I think the amount is 10 million. I have to double check, but I thought it was actually 1 million, which was the Netflix prize in 2006. That was awarded in 2009. Facebook has posted this onto Kaggle. This is a first-class Kaggle project. You can sign up right now. You can join. Just Google for Deepfake Detection Challenge. Our sponsorship extends. We're giving credits to the teams. Smooth onboarding. We've even created this deepfake detection challenge GitHub repo off the same data science on AWS as kind of a quick onboard on how to actually use your credits that you're given. So the way that you get credits for this challenge, and it's a significant amount of money. It's not, $25. It's not $70. It's in, I guess triple digits, right? This is it's like $200 or $500 or something. And how to create an S3 bucket, how to get the data down. Now, we can only get you as far as how to use the Amazon stuff without actually violating any, like Kaggle things. So I can't recommend any algorithms to you. But on Kaggle, they actually have samples and places to start. Okay? And there's some, pretty well-known. So, and specifically, this is videos. So this is like detecting fake videos. Okay? And there's some, very well-known techniques for this. You could look at eye blinks and, different things like that. These are all public. This is nothing specific to Amazon, but we'll, tell you how to get the instance set up. And some of you might have noticed that these sample notebooks are the exact ones that we just did during the workshop, the TensorFlow, PyTorch, MXNet. These actually do have the P3s still in them. One note, and so the way Kaggle works is you have to upload a model so that can be run on, how do I say this? You can't upload a SageMaker model, like a blazing text model or a factorization machine. This has to run in isolation because, obviously Facebook wants to take this and use it on their own and not have any cloud dependencies. But to be very clear, you can train the model with SageMaker, which is like the exact thing that we're doing here, and then exporting the model into the TensorFlow open source, and then submit that. Okay, so this is pretty much line for line exactly the same code that you're doing here for the workshop, and exporting as the save model. And then when you submit to Kaggle, you have to submit this model and the code that's going to load it and then make the predictions. Okay? So we have PyTorch example, MXNet example, and TensorFlow. So a good place to start. If you win the 10 million, just slide me a cheeseburger, or actually the Impossible Burger, because I'm all plant-based this year. That's my thing. Which I violated on New Year's Day. I had a big thing of chicken wings, but. Okay, and in about 10 minutes is going to be Kunal. Kunal, what are you talking about? Ground truth. Excellent. So if you guys have any questions, hopefully the other examples work. And once again, to recreate this after today, just change the instance type of the notebook that you're trying to use. So when you provision the instruction on provisioning the notebook, I chose the biggest one that I could in the T range that works with Event Engine. Just change that to one of the, instance types that your account actually allows. And then I think from that point, you should be okay. Yeah, any other closing things? And then I'm going to get some food. Yeah. Oh, the question was, and Kunal, do you know this? Yeah, by any chance? So, question came up where every time I invoke SageMaker, so let's take TensorFlow example. I'm giving the instance type here. I'm calling fit. If this only runs for 4 minutes, right? So does the customer get charged for only 4 minutes? Or is it the full hour? Or is it a minimum of 10 minutes kind of thing? Yeah. Yeah. Let's look it up. Also, while I'm thinking of it, note the ML prefix here. This is something that you'll spend hours on if someone doesn't tell you. This C5 is different because it has that like ML. So this is just the way that like Amazon does its internal accounting or is able to do capacity planning for C5s that are being used within SageMaker. So when you see ML dot, that's specific to SageMaker. You will likely, I'm pretty positive, you won't actually see quotas for this in your service like quota limit thing. You'll see that you have 2 C5s, but you don't have an ML C5, okay? And the short of it is you have to contact support if you do, and make sure you get the actual ML one. Okay, yeah, does that make sense? If you just have C5 for just regular, for just regular EC2, those don't work with SageMaker. It's very easy to get limit, like increases. You just have to know that there's ML dot. And this is a pattern I'm seeing in like other services as well too, where they're sort of isolating, and it's purely for capacity planning and management. If you do, I'm not going to change the code because I'll probably commit it, but if you do drop that ML dot, this will fail and say you aren't using the right instance type. Okay, and a quick precursor to this afternoon's workshop. This is actually from reInvent. This is what we'll be doing later on today. We'll be exploring a news data set and doing a bunch of cool stuff with it. This is where we'll actually be creating a Docker image with a custom TensorFlow model, actually Keras model. So Keras is a layer on top of TensorFlow. It's actually now been integrated with TensorFlow. It started off a separate project. Google hired that guy. Now it's part of TensorFlow. And really, you shouldn't ever be writing low-level TensorFlow code anymore. That would be the equivalent of writing like Java bytecode. Like, don't do that. You should be writing at the Keras level. And our examples that say TensorFlow are actually using Keras, but TensorFlow is the runtime and the framework. So, whereas Keras is an API. It's a subtle difference, but just know that TensorFlow and Keras basically are the same thing now. And this is a beast. This is the one I spent quite a bit of time last night. There's going to be lots of places where we need help, and I have to get you guys through. So it's not for the faint of heart, but I'll probably do it. I'm going to pre-run it and do just like I did earlier, where I showed you the results. And then if you get stuck and want to go home and actually, check in with work or say hi to your kids or something, feel free to do that. But this is totally reproducible, of course, afterward. Okay, if you have any other questions, let me know. And Kunal's going to kick in about 6 minutes. So thank you.